Hello. Am I audible? Yes, students, please talk with me. Am I audible? Is this screen visible to you? Okay. So, good morning, students. Today we'll start with Unit 3. Students are joining. So, recap of last lecture will take within 5 minutes. In last lecture, you have studied Unit 2. Okay. So, in Unit 2, you have studied time domain analysis. Okay. You have observed the response in time domain for first order system. You have observed the response in time domain for second order system, right? And you have studied the parameters related to second order systems. Okay. Now, in Unit 3, you are going to learn about frequency domain analysis. Okay. So let us see what happened in frequency domain analysis. Okay. So student, Unit 3 title is frequency domain analysis. Now, as usual, before starting directly Unit 3, I'm going to give you objective of this session. That is nothing but objective of Unit 3. So very first you have to remember objective, then outcome. Okay, that is nothing but learning outcome. So objective of this session is to study. Just wait. Objective of this session is to introduce the concept of root locus, body plot, Nyquist plot. Related. Now all these plots are related to frequency domain analysis. Okay. Now after studying all these things contained under Unit 3, students should be able to do this. This is nothing but your learning outcome, or you can say course outcome for our course control system. So what is outcome? Outcome is this: to perform frequency domain analysis using frequency plots. All these are frequency plots required for stability analysis. Now, depending on this plot, we are going to conclude whether our system under consideration is stable or not stable. Stable or unstable or marginally stable. Okay. Now let us proceed. Now these are the contents of Unit 3. Unit 3 is frequency domain analysis. In frequency domain analysis, you are going to study need of frequency domain analysis. What are the advantages? What is need of frequency domain analysis? Then correlation between time and frequency domain. Then frequency domain specifications, bandwidth. Then you are going to study body plot, how to draw a body plot, construction of body plot. Okay. First of all, we are going to solve the numerical related to this body plot, and then we are going to plot this body plot on graph paper. That is nothing but construction of body plot. Okay. Then what is gain and phase margin, that you are going to learn. Then determination of relative stability. The concept of stability is introduced over here in Unit 3, but all the details related to stability you are going to study under Unit 4. Okay. So here you are going to study determination of relative stability, then Nyquist plot, Nyquist stability criteria, then relative stability using Nyquist criteria. So up to this point, you are going to study stability. Okay. Under Unit 3. Okay. And all details related to stability you are going to study under Unit 4. So let us start with frequency response. So these are the contents you are going to study. In short, I have given. Now, very first is nothing but frequency response. Now, what is meaning of this frequency response? So you might have been studied this frequency response related to your amplifier circuit. Okay. In second year, first semester. So you have observed the frequency response of common emitter amplifier. Okay. So what is frequency response? Frequency response is nothing but you will get output when input applied is sinusoidal signal. So you have applied sinusoidal input to your amplifier circuit and you have plotted the frequency response. So this is the meaning of frequency response. You will get output when you have applied input as sinusoidal signal. Now in this control system, you are going to apply sinusoidal input. you will get the output. Okay, same output of steady state. Steady state output you will get, but in terms of sinusoidal signal again, and there will be phase shift between input and output. That is nothing but frequency response. Okay, so let us see the proper definition of frequency response. What are the advantages of frequency domain analysis? Okay, so students, are you with me up to this? Please be ready with your notebook, pen. You are supposed to write the important points related to frequency domain analysis. So give the heading, Unit 3, frequency domain analysis. Now, very first is nothing but what is need? What are the advantages of frequency domain analysis? That you should know initially. So, a perspective on the frequency response design method. The design of feedback control system in industrial area, in industry, is probably accomplished using frequency response method more than any other method. So in industrial field, they prefer this analysis, frequency response design method and analysis, okay, rather than any other method. So what are the advantages of this frequency response design that you are going to study? So these are some of the advantages listed over here. So give the heading, advantages of frequency response design. Very first is this frequency response design provides good designs in the face of uncertainty in the plant model. Important advantage of frequency response design method. Second, experimental information can be used for design purposes. So raw measurements of output amplitude and phase of the plant undergoing a sinusoidal input excitation are sufficient to design a suitable feedback control system. Okay, which is the input? Input excitation used is sinusoidal input. Okay, no intermediate processing of the data, that is nothing but such as finding poles and zeros, that is not needed over here. So no intermediate processing of data is required to arrive at the system model. So here you are not going to find out the poles and zeros, all these things, or roots of characteristics equation. हे अजिबात काही करायचं नाही. So no intermediate processing of data is required to arrive at the system model. So these are the advantages of frequency response design method, and hence we are using frequency domain analysis. Now, please try to understand the meaning of this word frequency response. Just I have explained, but in proper definition, you are supposed to write what is frequency response. So the frequency response is defined as, you are supposed to write this term, frequency response. Very important term. The frequency response of a system is defined as, it is a steady state response of the system to a sinusoidal input signal. Frequency response of a system is defined as the steady state response of the system to a sinusoidal input. So this is our system. This is your control system, right? You know, control system is represented by process. It is represented by feedback element. So this is nothing but our closed loop control system, block diagram, simple block diagram of closed loop control system. Okay, in which this block is nothing but your process with transfer function g of s, and the second block is nothing but your feedback element with transfer function yes, h of s. This is nothing but your summing point. Okay, this is nothing but your input signal. RT is equal to R into sine omega 0 t. So we have applied input signal. Which type of input signal? Sinusoidal input signal. This R is nothing but constant amplitude with this frequency omega 0 into t. So what is input? Input is sinusoidal in nature with this equation, similar to your Vm sine omega t. So we have applied R sine omega t is nothing but input to this closed loop control system, right? And what is output? Output is yt. Output is equal to y sine omega 0 t plus phi. So input is also sinusoidal signal, output is also sinusoidal signal with some phase difference. So I have added this term plus phi, bracket complete. So what is the equation for output? Yt is equal to y sine into bracket omega t plus phi, omega 0 t plus phi. So this is the equation for output. This is the sinusoidal input. So input and output both are sinusoidal in nature, but output is phase shifted to that of input signal. This is nothing but frequency response. Okay. So for LTI system, what is LTI system? Linear, yes, time invariant system. So for a LTI system, when input to the system, it is sinusoidal signal. It is a sinusoidal signal. Okay. The resulting output as well as the signal throughout the system is nothing but sinusoidal in steady state. Okay. And the output differs from the input waveform only in amplitude and phase, but nature of output waveform is sinusoidal. So that output differs from the input signal, okay, or input signal waveform only in amplitude and phase. बघा इथे amplitude change झालाय. What is amplitude of input sinusoidal signal? It is R. Frequency remains same, omega 0 t, omega 0 t. Okay, sinusoidal signal both are input and output. What is change? Change in amplitude and change in phase only at the output, and hence output differs from the input waveform only in terms of magnitude, or you can say amplitude and phase phi. Okay, is this clear? What is frequency response? Any doubt up to this? Okay, proceed further. Now we are interested in closed loop transfer function for LTI system. So you are going to write the equation for closed loop transfer function. Now you know very well what is the equation for closed loop transfer function. Standard equation for transfer function in case of closed loop control system is equal to, yes, transfer function is equal to G of S divided by 1 plus G of S into H of S. So this is the equation for transfer function. You have studied in time domain analysis, right? So the same equation we are going to use over here in frequency domain analysis. Just you have to replace this S by J omega. Okay, so consider our LTI system, and we are going to write the transfer function for closed loop control system. Okay, so transfer function for closed loop control system, transfer function we are going to denote in this unit 3, that is frequency domain analysis. We are going to denote our transfer function by this variable m of s. And what is definition of transfer function? Transfer function is nothing but ratio of Laplace of output to the Laplace of input. So ms is equal to, now see here, what is input? Input is r of t, output is y of t. So taking Laplace of output to the Laplace of input, ratio of Laplace of output, that is y of s, to the Laplace of input, that is r of s, is nothing but transfer function in frequency domain analysis, and that we are going to denote by letter capital M of S is closed loop transfer function for LTI system is equal to y of s divided by r of s is equal to, now you know this equation, g of s divided by 1 plus g of s into h of s. Now this is the equation for transfer function for closed loop control system. This is the equation for transfer function. Now for frequency domain analysis, what we are going to do? For frequency domain analysis, you just replace this s by j omega and rewrite the equation. So m of s, that becomes m of j omega, replace s by j omega in frequency domain analysis. Well, it's very simple. Just you have to replace the variable s in this equation by j omega. So ms is nothing but m of j omega is equal to yj omega divided by rj omega is equal to, Now this equation, just replace S by J omega. So you will get this equation in frequency domain analysis by replacing S by J omega. So you'll get transfer function equation for closed loop in frequency domain analysis is equal to G J omega divided by 1 plus G J omega into H J omega. Now this is the transfer function in frequency domain analysis. This is the transfer function of closed loop control system in frequency domain analysis. Student, you are supposed to write this equation. This equation is very important. Okay. Now we are going to calculate magnitude and phase of this. In frequency domain analysis, two terms are important. First one is magnitude and second one is phase. That is nothing but y and phi, right? So in frequency domain analysis, the frequency domain transfer function mj omega is represented in terms of two parameters. That is nothing but this mj omega you can express in terms of its magnitude and phase. So how to write equation for this frequency domain transfer function mj omega is equal to mod of mj omega into angle of mj omega. So this term is nothing but first term, this term, mod of this mj omega is nothing but magnitude of your frequency domain transfer function mj omega, whereas this term angle of mj omega is nothing but phase of your frequency domain transfer function mj omega. Got it? So in frequency domain analysis, you will get your transfer function into two terms. So your transfer function you can express in terms of magnitude. So what is magnitude? Magnitude is equal to mod of mj omega. Okay. You have to take mod of this equation. That means mod of this equation. Gj omega divided by 1 plus Gj omega into Hj omega. So take mod of this, you will get magnitude of mj omega. Take angle of this mj omega, you will get phase phi. So you know equation output y is equal to y of t is equal to capital Y into sine of omega 0 t plus phi. So that magnitude y is nothing but this term. Okay. So magnitude, for finding the magnitude in frequency domain transfer function, you have to take mod of this mj omega. And while calculating phase, you have to take angle of this mj omega. Or in US way, angle of mj omega is nothing but your phase phi, whereas mod of mj omega is nothing but magnitude. So write these two terms. Are you with me, students? So all these steps you have to write in your notebook. So take your pen, notebook, to write all these things. Okay. Now, how to calculate magnitude? So in frequency domain analysis, the magnitude of mj omega is given by this equation. Magnitude is nothing but you have to take mod of this. So how to take mod of this? Mod mj omega is equal to mod of this transfer function. So what is transfer function? Mod of gj omega divided by 1 plus gj omega into hj omega. Okay. So you can write this equation. Just wait. Okay. You can write this equation mod of j omega like this is equal to mod of numerator and mod of denominator, modulus. Mod of gj omega divided by mod of 1 plus gj omega hj omega, right? Simplify, you will get magnitude of mj omega in frequency domain analysis. So first term, you got it, magnitude. Now talk about phase. Now this equation is nothing but gain characteristics in frequency domain analysis. This above equation, we are calling this equation as gain characteristics of your transfer function in frequency domain analysis. Now let us talk about phase, second part. So you can calculate phase of this mj omega is equal to angle mj omega is equal to phi m j omega. So while taking angle of this, you can write gj omega, angle of gj omega divided by term जो है, you are going to take minus. So angle of gj omega minus angle of this term, angle of bracket में 1 plus gj omega into xj omega, bracket complete. So this is how you have to take angle. Okay, divided by terms जे आहे ती काय घेतो आपण, minus angle of 1 plus gj omega into hj omega. Okay, got it? Now this equation is nothing but phase characteristics of your transfer function. So your transfer function is having two characteristics, gain characteristics and phase characteristics. Okay, and these are the equations for magnitude of nj omega. So take mod of this, you will get magnitude of j omega. Okay, now for phase of nj omega, you have to remember this equation. Okay, angle of gj omega minus angle of this denominator term. So this equation is nothing but your phase characteristics, whereas for this is nothing but your gain characteristics. Now, is this clear? Understood?
Yes, ma'am.
Now coming to this, if your equation is like this, mj omega is equal to, for example, I have given mj omega is equal to a for omega, that is angular frequency omega is less than or equal to omega c. Omega c is cutoff frequency, and mj omega is equal to 0 when omega is greater than omega c. Now just by observing this equation, you will come to know which type of response is this. Okay, हा response कुठल्या सर्किटचा आहे ते तुम्हाला लक्षात येते बघा मुलांना. If you have studied the filter circuits. Okay, now I am going to explain this. mj omega on y-axis I have taken mod of mj omega, on x-axis I have taken frequency omega. Okay, so you can plot this response like this. mj omega is equal to a. So mj omega is equal to a. A is constant, that is amplitude of your circuit. So mj omega, mod of mj omega is equal to a. So I have taken mod of mj omega on y-axis is equal to a. A is here. When omega is equal to less than or equal to omega c. So see here, this is your omega. When this omega is less than or equal to omega c, that means from this point, before this point, less than and equal to means before this point omega c. This frequency is less as compared to omega c or is equal to omega c. So from 0 to omega c, the amplitude of this magnitude of mj omega is equal to a. So I have drawn this line a. Okay, I have drawn this line a up to from 0 to omega c. What is next important remaining part? Mod of j omega is equal to 0 when omega is greater than omega c. So I have drawn this is equal to 0 when omega is greater than omega c. Omega c पेक्षा greater जे काही frequencies आहेत त्याचा amplitude किती आहे, magnitude किती आहे, is equal to 0. So is equal to 0. Now this is the response of your low pass filter. Are you agree with me? Lower frequency is passing, whereas higher frequency is eliminating or attenuated or eliminated, you can say. So this is the gain characteristics of an ideal low pass filter. This one is nothing but gain characteristics of an ideal low pass filter. Ideal low pass filter असेल तर gain characteristics कसे असणार आहे, as shown in this graph. Okay, now the second one is phase characteristics of ideal low pass filter. So this is nothing but phase characteristics of ideal low pass filter. Okay, with respect to, this is the phase, and this is nothing but phase with respect to omega. This is the phase characteristics of an ideal low pass filter. So this one is gain characteristics, this one is phase characteristics of ideal low pass filter. So you have to remember this one. I have given small example, okay, of low pass filter. Chalo, understood? Any doubt up to this? Student, you have to write this equation for magnitude of mj omega. In frequency domain analysis, you have to write equation for this phase of mj omega, because while solving numerical, you need these two equations. You have to calculate magnitude. So remember this equation. You have to take mod of this. Okay. For calculation of magnitude, you have to find phase of mj omega. So remember this equation. And these two equations are nothing but gain characteristics and phase characteristics of closed loop transfer function in frequency domain analysis. So remember these two equations. Have you written this? I have given small example of ideal low pass filter. So this is the gain characteristics, this is the phase characteristics. Are you with me, students? Any doubt up to this?
No, ma'am.
Okay. चलो आगे चलते हैं. Take small example. Very simple example I am going to take. So you might have studied the frequency dependent component. So frequency sensitive, or you can say frequency dependent components are nothing but capacitor and inductor. So take a very simple example of capacitor. Only one capacitor. Apply input, take output. Okay. So student, you are supposed to write this example. You might have been studied the response and equation for current and voltage for capacitor in electrical, basic electrical engineering. हे तुम्ही शिकला आहात मुलांनो. So the same example I have taken over here in order to understand, in order to explain the frequency domain analysis. Okay. So write example, frequency response of a capacitor. Consider capacitor described by this equation. So you know the equation for current flowing through capacitor when input voltage is applied to it. So what is the equation for current flowing through capacitor? That is given by this equation. I is equal to value of capacitor into dV by dt. Now this is the equation for capacitor current flowing through your capacitor. So write this equation. Current flowing through your capacitor, I is equal to C into dV by dt. So here input is voltage V. V is the input voltage, whereas I, current, is nothing but your output. So this I, current flowing through your capacitor, is nothing but your output, whereas this V is nothing but your input voltage. And you have written the equation for current flowing through capacitor when input voltage is applied to capacitor. Okay. And that equation is nothing but I is equal to C into dV by dt. Now take Laplace transform of this. Now you have to determine the sinusoidal steady state response of this capacitor. Now you know very well what is response. Now here you are going to determine the sinusoidal steady state response of capacitor. Meaning is that, what is meaning? Input is voltage, output is current in this example. Okay. With sinusoidal input is nothing but sinusoidal steady state response of capacitor. Now, first of all, write solution. You can draw the circuit also. Draw the symbol of capacitor. Give input voltage V and output is current flowing through it, the capacitor. Okay. From input to output. Now determine sinusoidal steady state response of the capacitor. Solution. The transfer function of the capacitor is, what is transfer function? Transfer function is nothing but ratio of output to the input. Laplace of output to the Laplace transform of input. Again, I am repeating. Yes, I got your point. Please write the definition of transfer function. Transfer function is nothing but a ratio of Laplace of output, Laplace transform of output to the Laplace transform of input. Now, in our example, what is input? Input is voltage, V is input, and output is current. Okay, so this I is output, this voltage is input. So equation for capacitor current is I is equal to C into dV by dt. So the same equation I have written over here by taking Laplace transform. Okay, transfer function is nothing but ratio of output to the input. Laplace of output to the Laplace of input. In our case, output is current, so I have taken I of S. In our case, input is voltage divided by input, Laplace of input. So I have taken V of S. This is nothing but transfer function for capacitor. Okay, I of S divided by V of S is nothing but transfer function of capacitor. Okay, is equal to, in frequency domain analysis, this transfer function is denoted by letter M. So is equal to M of S. Now take Laplace transform of this term, C into dV by dt. So you can write C as constant as it is. So C as it is. Okay. Into V of S we have taken on this side. Okay. dV by dt is remaining. So dV by dt, Laplace transform of this is nothing but S. So you can write like this. You can write like this. C, capital C, into dV by dt, like this, dt, okay, into V of S, into V of S, like this you can write, V of S, okay, is equal to, again, second term मध्ये काय राहणार आहे आपलं, V of S आपण इकडे घेतला, so better to write like this over here, I of S is equal to, I of S is equal to, right, I of S is equal to capital C is nothing but capacitor into dV by dt into V of S. Okay, so what I have done, I have taken this V of S divided by, so I of S, are you with me students? I of S, capital capital V of S, I of S is equal to, काय केलं मी, is equal to मी काय केलंय, C as it is into dV by dt is nothing but your S, right, into V of S आहे, into V of S आहे, बरोबर, into V of S, right. So what I have taken, I of S divided by V of S. My next line is I of S, small s, is equal to C of S, एक मिनिट, divided by करून घेते, is equal to V of S. V of S now is equal to, just a second, is equal to, what is remaining, C into S, right. So what is transfer function for this? Transfer function is equal to, that is denoted by letter M of S in frequency domain analysis, is equal to I of S divided by V of S. I of S is nothing but output, current is output, and voltage is input. Okay, so I have taken the ratio of Laplace of output to the Laplace of input. I of S divided by V of S is equal to M of S. MS is nothing but, you can represent your transfer function in frequency domain analysis by M of S is equal to C into S. So I got C into S. The same equation I have written over here. And this is how you will get this equation. I of S is equal to V of S is equal to C into S. Okay. Now, in frequency domain analysis, we have to replace this S by, yes, S by J omega. So M of J omega is equal to C into J omega. What you have done? You have replaced S by J omega in frequency domain analysis. That's it. Okay. हे झालं. Now compute magnitude and phase. So after getting the equation for transfer function for capacitor, so equation for transfer function in frequency domain analysis is equal to m of j omega is equal to c into j omega. Now this is the equation for transfer function for capacitor in frequency domain analysis, right? So what you have to do next step, you have to find magnitude and phase. So find out magnitude and phase for this equation. This is the transfer function equations. How to find magnitude? In order to find the magnitude, what you have to do? You have to take mod of this, right? So I have given equation, student, to find out magnitude. So magnitude of mj omega is nothing but you have to take mod of this equation. याचं काय करायचं आपल्याला mod घ्यायचा आहे. Okay. And in order to find phase of mj omega, what you have to take? You have to take angle. Okay. So find out mod of mj omega is equal to mod of cj omega. So mod of cj omega is equal to c into omega. C into omega. Now magnitude, find out. So you have to take angle of this, angle of mj omega. In order to find phase, you have to take angle of this. So angle of this mj omega is equal to phi m is equal to 90 degree, right? Is equal to 90 degree. So you know there is a phase difference. Okay. So dv by dt of voltage is sinusoidal in nature, right? So dv by dt sine omega t is nothing but cos omega t. So there is a phase difference between input and output. So input and output is phase shifted by 90 degree. Got my point? When sinusoidal signal is having maximum amplitude, at that time the output signal is having amplitude is equal to 0. That you know very well. So phi is equal to 90 degree. So you got the amplitude or magnitude and phase for capacitor. Okay. So what is magnitude? Magnitude is equal to c omega and phase is equal to 90 degree. There is a 90 degree phase shift between input and output. So phase is equal to 90 degree. Now this is how you can solve the example. Okay. Just I have taken simple example. So magnitude we got is equal to c omega and phase is equal to 90 degree. Are you with me, students? Now this magnitude is nothing but gain characteristics and the phase is nothing but phase characteristics. Okay. This magnitude mod of mj omega is equal to mod of cj omega is equal to c omega is nothing but gain characteristics equation in frequency domain analysis. Okay. For our example. And what about phase characteristics? Phase characteristics is nothing but, yes, phase equation. So angle of mj omega is equal to phi m is equal to 90 degree phase shift. Okay. Now output is equal to, output is ij omega is equal to mj omega into vj omega. Mj omega is nothing but transfer function. Vj omega is nothing but your input signal. So output is equal to transfer function into input in frequency domain analysis. And hence I have written ij omega is equal to mj omega is the transfer function in frequency domain analysis into input. Input is vj omega. So this is the equation for output current. In our case, current is output, voltage is input. And this is the equation for gain characteristics. This is nothing but phase characteristics. This is magnitude, this is phase. Okay. This is the equation for output. Ij omega is equal to mj omega into vj omega. Mj omega is the transfer function in frequency domain analysis, and vj omega is nothing but your input applied signal. This ij omega is nothing but output. So for unit amplitude sinusoidal input signal voltage, the output current will be sinusoidal in nature with the magnitude is equal to C omega. Okay. And the phase of output that will lead the input by 90 degree. This is the phase. Meaning is that for a unit amplitude sinusoidal input signal voltage, the output current will be sinusoidal with magnitude C omega, and phase is nothing but 90 degree, but the phase of output will lead to that of input by 90 degree, right? Because the equation is I is equal to C into dV by dt, right? So leading the input by output is leading to that of input by 90 degree. Okay. Now note that for this example, the magnitude is proportional to the input frequency, that is omega. Magnitude is proportional to input frequency, whereas the phase is independent on input frequency. There is no any frequency component present in this equation. So your phase is independent on frequency, whereas magnitude is directly proportional to the input frequency. So this is the conclusion we have got from our example, and that's why you have to note this. For this example, the magnitude is proportional to this magnitude. Okay. Nj omega is nothing but magnitude of your capacitor in frequency response, that is proportional to frequency, input frequency omega, whereas there is no any relation between input frequency and phase. So we can say phase is independent of frequency. Got my point? Any doubt up to this? Any doubt, student? No doubt. Okay, understood?
Yes, ma'am.
Now, frequency domain specifications. So you should know some of the parameters related to frequency domain analysis. So these are some of the frequency domain specifications I'm going to explain over here. So now here in this unit, you are going to plot this frequency response. Okay. So how to plot? In frequency domain analysis, two parts are important. One is magnitude and second one is phase. Okay. Magnitude is denoted by this letter mod of nj omega, and phase is denoted by angle of nj omega, or you can write phi m j omega or angle of nj omega. Magnitude and phase, these two parameters or specifications are very important in frequency domain analysis. Okay. Now, for example, this is the plot for low pass filter set. This is the plot for low pass filter. Okay. For example. Okay. So this point is nothing but your resonant peak, maximum value of resonant. That is nothing but peak value. So peak value of your resonant is nothing but this MR. So MR is represented as resonant peak or maximum value of resonant. Okay. Now this is nothing but 0.707% of maximum value of peak value. Okay. This is nothing but your cutoff rate. With this rate, your response is decreasing. Okay. This omega R is nothing but your resonant frequency. Omega R is nothing but your resonant frequency. Okay. And from this point, 0 to this point, this much is nothing but your bandwidth. BW is nothing but bandwidth. Okay. On x-axis, we have taken frequency. On y-axis, we have taken magnitude. Here also in phase plot, we have taken on x-axis frequency omega, and on y-axis in negative side, we have taken phase. Okay. So this is nothing but magnitude of your response, magnitude response of the given example. This is nothing but phase response of given example. Okay. And you can write this equation for omega R, that is nothing but resonant frequency is equal to derivative of this magnitude with respect to omega is equal to 0. This is nothing but equation for resonant frequency. Okay, so these are some of the specifications you have to remember in frequency domain analysis. What you have to remember? You have to remember MR, that is maximum resonant point or peak resonant at this point. Okay, this is nothing but your resonant frequency. So at resonant frequency, you'll get maximum amplitude or magnitude of your response, frequency response. Okay, and if you are going to take 0.707 of this magnitude, you will get this 2 point. So join this 2 point. Okay, and from this point to this point, this is nothing but your bandwidth. Okay, so we can calculate this resonant frequency by using this equation. Okay, take derivative of magnitude is equal to 0. This is nothing but equation for resonant frequency omega r. So this is magnitude plot, this is phase plot for our equation. So these are the frequency domain specifications. You have to remember MR, maximum resonant point or peak point, or maximum amplitude or magnitude, you can say, that is denoted by letter capital M suffix R, then resonant frequency omega r, and this is nothing but bandwidth of low pass filter, you can say. Any doubt up to this?
Any doubt,
Understood,
student?
students? Thank you very much. So in today's lecture, students, you have studied frequency domain analysis. Okay, so what you have studied? I have taken one example of capacitor only. Capacitor is frequency sensitive component, right? So input signal is applied to capacitor, that is voltage. Output of capacitor circuit is nothing but current. So we have calculated the magnitude for this capacitor circuit in frequency domain analysis, that is nothing but frequency response. What is magnitude? Magnitude is equal to C into omega, that is nothing but gain characteristics. So how to calculate magnitude? Take mod of this. Okay, so magnitude is equal to C into omega, whereas phase is nothing but angle of that equation, and that is nothing but phase characteristics is equal to, yes, 90-degree phase shift we got between input and output, and we have plotted the response. And these are some of the frequency domain specifications, MR, omega r, and bandwidth. For example, I have taken. Any doubt up to this? Understood? Clearly? Absolutely clear? Okay. Thank you, students, for attending. Now, please write your roll number in chat box. Then you are free to move. Write with understanding. Write your roll number with understanding in chat box. Then you are free to move. Thank you.
So thank you, students. Any doubt?